In this module, we're going to start learning how to access data from within a database. We'll be using relational algebra to do that, and this sets us up for later on being able to write a lot better SQL statements. If we can learn how to actually use relational algebra and see how we actually get to the data and can retrieve it, it'll make writing the SQL statements a lot easier. Before we get going, for this week, I'd like you to make sure you download this handout. It's Relational Algebra Operators. Okay? And this is what's in it. Okay? You will be using these symbols in your statements that you write, along with the symbols here. So there we have a less than or equal to symbol. You'll need to use that in your relational algebra and not a less than followed by an equal. Okay, so need to pay attention to the syntax and just copy and paste these symbols. It's presented to you in a Word document so you can do that easily. And this is what we'll be what you'll all be learning is how to use these symbols to be able to access that data. I do have some templates here and they're on the next page. And this shows you how the relational algebra statements can be set up. There are some that parts of these statements are subscripted. And this is a picture, so I can't highlight it, but this from the opening parenthesis through this closing parenthesis around attribute, that's subscripted. To get a subscript in Word, you can use this little button right up here. You just click it and start typing, and you're in subscript. You unclick it, and you're back to normal script. So you will need to write using subscript. You will be submitting a Word document. So if I have any questions, I'll go check to see if you subscripted, because I've had students that they decide not to subscript and they'll write something in a big font and then they'll try to lower the font down to like 2 or 3 points, and that's not subscripting. Okay? So please make sure you use subscripts appropriately. Okay? All your relational algebra statements need to follow the format in these templates. Okay? And you can read over that, and you'll see when I'm doing it, I actually have you do something that's not in the book. I have you write your relational algebra statement, but then in the resulting relation, I want you to tell me what attributes are in that relation. Okay? The reason I do that is I find some students, they really don't understand what the RA statements are doing, and therefore they have no clue really about how to attack the problem. They just write a bunch of random relational algebra statements. I want you all to focus on what you're doing and what the statement is actually going to pull from the database. Okay. All right, and there's a few examples here. Okay. Also, there is only one operator that you can combine on a line with another operator, and that is row, and that's for rename, and we'll get to that. But I don't want you combining, there's the project operator and the select operator. Those should not ever be combined on a row in the table that you're going to be creating. The reason for that is I want you all to demonstrate that you actually know what the select's doing and then what the project is doing. Okay? And as I talk through the rest of this video, you'll get to see this in action, and it might make a little more sense then. Okay, so that's it for the introduction. We'll get started with the select operator here. Okay, the select operator is the first thing that we're going to talk about here, the first relational algebra operator. Okay? And what a select does is it chooses a subset of tuples from within a relation. And the subset it chooses is whatever matches this select condition. Okay? We use the lowercase sigma as the operator. We subscript this parenthesis, the select condition, and then close parenthesis. We put a relation inside parentheses after the select condition, and that relation and parentheses are not subscripted. The select condition itself, here's a few things about it. Let me get them on here. And this what would be right in here. We can have an attribute name, a comparison operator, and a constant value, or we could have another attribute name, either one. Okay. The comparison operators you'll use are those, and those operators are in our relational algebra handout, and they're back up here. Okay. Those are available to you. So is the lowercase sigma right there. And I'd highly recommend that you copy from these operators. Now, and or not, obviously, you don't need to worry about that. Equal sign, a less than or greater than, those are okay. You won't be using a natural join, so you don't need to worry about that one. So several of the things you can, are just a few, I shouldn't say several, just a few of the things you can just type. The rest of them, I would make sure that you copy from here just so you get them right. So there's our syntax. There's the comparison operators. You can also have a select condition like this, and then have a keyword and or not. Well, it wouldn't be, you could use not by itself, I guess, and then add another condition. So you will also be assigning the results, as I said in the introduction there. Let me copy it over here. You will be assigning the results to an intermediate relation, and it'll look like this. Whatever relation name you want to call it here, the last relation you relate these intermediate relations that you create, it needs to be a named result. Okay? And you'll see how I do them. I usually start at the top, result 1, 2, 3, 4 as we're going down, and then end up with just a plain old result. Okay? But it is a relation name. This is not a base table. For this week here, this relation, the first one that we use in a sequence of RA statements, will be a base table, meaning that for the demonstrations I'm doing, it will be based off one of these tables within the company database. When you're doing your homework, it'll be based off tables that are in the My Guitar Shop database. But we're only going to work on one table per question, or per in the assignment this time. And when I say one table, it's one base table. You will be creating intermediate relations. Okay, those don't count. But you're going to start with selecting from something from department or from employee, from one of those relations. Okay. So let's see how one actually looks. So I've got a few examples here I'll bring up. Let me just cut one over here and paste it. There. If we want to select the employees who earn more than 30,000, this is what it would look like. We're using the lowercase sigma operator. Okay, we have our select condition here. Salary greater than 30,000. This needs to be an attribute name in the employee database, or in the employee table in the company database. Okay. When you're doing your homework, it will be a table. You'll have the relation here, or the table, and that will be one of the tables in the My Guitar Shop. Whichever table you use, you'll be using attributes from within that table. And we can see here in the employee table, salary is one of the attributes. So what this will do is it will return the employees that make more than 30,000. So if we looked in our company database here, we would get Franklin, Jennifer, Ramesh, and James. Those are the rows that would return because those folks make more than $30,000. And as we go through this, I want to at times show you the equivalent SQL statement. Now I know we haven't got to the SQL chapter yet, but I want to show you what this actually looks like and what will happen when we run it. Okay. So let's go ahead and take a look at what this is in SQL. We're saying select star. Okay. And again, the select returns a tuple. It does not pick attributes, it returns everything in the tuple. Then we say from which table we're using, and then here is the select condition that we had, salary greater than 30,000. So if I run that, notice we get every single attribute that's in the employee table. And then we get only the employees who had a salary greater than 30,000. So this SQL statement is equivalent to what we have right here. Okay? That gives us the employees that earn more than 30,000. Let's look at another example here. Here, select the department whose department number is equal to 5. Okay? We go in the department table, and that's one of the first things that you'll need to find out is which table is the information in. So make sure you read what's being asked for. Okay, so we're selecting the department. This isn't selecting an employee whose DNO is 5. We're selecting the department. Okay, so we're in the department table. Where it's equal to 5, we're returning all attributes. Okay, so let's go back over to MySQL, and I'll change this real quick. This was department, and we wanted the D number equal to 5. Again, we're returning all attributes from the department table, and here's our select condition. That select condition is this right there, D number equal 5. Okay, so when I run this, there, it returned the research department. That's D number 5, and it has all 4 attributes. Okay? So it picked the tuple and returned that. We can also concatenate these join conditions. Let's see how that looks like. Okay? We say select the employee who earns more than 40,000 and they work in department 4. So we say, well, I guess I used the wrong operator there. I said greater, more, so that should be greater than 40,000. Okay? And DNO is equal to 4. Right? So let's see what we would have to do to get this output. Okay, so let me go back over here. I'm going to change back to the employee. And we wanted a salary more than 40,000 and the DNO equal to 4. So I would say 40,000 and DNO equal to 4. I could run that, and we only get Jennifer. She's the only person in our company that works in department number 4 who earns more than 40,000. So that's giving you an idea of how this is working, how the select statements are working. All right. Next, we're going to look at the project and how we get certain attributes out. Okay, now we're going to look at the project operator. And the purpose of the project operator is to pull attributes from a tuple. Okay? The project operator will return either all tuples from the relation unless there's some duplicates. If there's any duplicates, it will get rid of duplicates. So as an example, in the company database, if we were just to pull dependent name, we would have only 6 dependents returned because Alice is in there twice. We got 2 Alices as dependents, one for different employees. Okay? So if we just projected dependent name, we wouldn't get any duplicates. So we would have fewer tuples than what is in the base table. But that's okay. If these were all unique names, then we would return them all. If we returned all of the projected the first names from the employee table, we would bring out all 8 first names because they're different. Okay? So that's the purpose of the project operator, is to pull attributes from a relation. And again, you will be needing to write like this. You'll be assigning it to an intermediate relation. Then you'll have a column where you actually talk about the attributes that are in it. Okay? But so let's take a look at an example or two here. First one, we're going to list the first and last names of all employees. Okay. To do that, this is what it would look like. Okay? We've got our pi symbol. We've got the attributes that we want to list. Okay? Then we have that base table or the relation. Then this is pulling, it's not pulling all attributes. This is actually just pulling F name and L name. So that's how you would write that. Okay. So we are just pulling attributes here. We are, unless there's duplicates, those duplicates would not be saved. Okay? We just keep one copy of it. But other than that, it'll return all tuples within a table. Okay? So let's look at another example here. Now let's look at another example here. We can list all project names and their locations. Okay? We go ahead and use the project operator, pi, specify the attributes we want and the relation we want. The resulting relation, well, this result right here, will only have the p name and p location from the project table in it. So that's how we go ahead and just get the attributes we want. Okay? We use pi, the project operator, an attribute list, and then the relation we're pulling the attributes from. Okay? Next, we're going to take a look at how we combine select and project together. Okay, we've seen how select works and we've seen how project works, and those are definitely useful, but by themselves they don't do much. So we're going to start using operators together, okay, to do things a little more powerful than each of the operators could do by themselves. Right, so let's take a look at how we combine these. All right, so I show here, list the department name for any department whose manager started before 1990. Now, if you notice, I put these on separate lines. Back in this round here, if you look at this, it'll tell you, make sure you read this, okay? Because it is possible to combine these all on one line. I do not want you to do that in this class. The reason being is I want to make sure you understand what the select's doing and what the project is doing. Because I found when I let students combine the operators on one line, the results were not very good. Quite a few did very, very poorly on the relational algebra. Okay? So that's why I want you to break these out. Okay? So here, list the department name for any department whose manager started for 90. Okay, so right here, that is our select condition. Okay? We want to know the department where the manager started before 1990. This, when I say list, that is what we're going to project. Okay. So if you'll notice here, I've got select where the manager start date is before January 1st of 1990. And I put the base table name there. Then I called that intermediate result, result 1, and it has all attributes from the department table. Then I use this intermediate relation in the next statement. So I'm taking from result 1, which has all attributes from the department table, and I am projecting the D name. Okay? So my result is I'll have result that has all of the department names in it. We'll just have one attribute with all the department names. So there's an idea of how we can combine things. Now, one thing to take in note, if I would have done this in this order, okay, I would not be able to do it. Reason being, I would have to change this to result 1 and use result 1 over here. Okay, but I won't, not going to bother doing, not going to bother renaming everything. But instead of department, I would put result there. Well, I couldn't do that because manager start date is not in there. Okay, I projected D name, so that means the manager start date, the D number, the manager SSN, they're no longer available to us. Okay? just so you know, we're not actually doing anything to the database itself. We're only querying the database. Okay? But if I would do a project before I did the select, it wouldn't work because I would not have the attributes necessary to make it work. So let's go ahead and put it back the way it should. Let's look at another example now. Okay, I want to list the first and last names of employees that make more than $30,000. And again, notice where I'm doing the selecting. I'm doing it before projecting. For most of the things you'll do on the assignments in the exam, a project is probably going to be one of the last things you do. You might have to do some projects in between, okay, depending on what operators we're using. But when it comes down to it, list the first and last name. That's my project. That's where I'm doing my project. The employee who makes more than 30,000, that's my select condition, and that's what I have right there. Okay. When I do the select, I don't limit the attributes coming back, so I get this star means all attributes in the table. When I do a project, I'm only projecting those attributes. So result only has first name and last name in it, and they came from the employee table. Okay. So that's how we can go ahead and start combining these attributes to solve the problem. Another thing I'll talk about now, you'll see on the assignments. I will give you some relational algebra, and I ask you to write it in plain English. Okay. Your plain English should be something like this. Okay? It should not be from the department table, compare salary so it's greater than 30,000, and then we will project the first name and last name from the intermediate relation. That is not the plain English. What I mean by plain English is this is how a business user would talk to you. This is how they would say, I want you to give me something that lists the first and last names of the employees who make more than 30,000. That's how a business person is going to talk to you, and that's what I mean when I say plain English. I want you to give me pretty much similar. It's not all the way, because sometimes I have to do a few other things just to make sure that you give you some hints on how to solve the problem. But for the most part, it's how I'm writing these problems. That's the plain English. So when I ask you for that, if I would have just showed you just this table right here and say write the plain English for it, a good answer would be right there. You know, list the first and last name of the employees who make more than 30,000. You could have just said list the names of the employees who make more than 30,000, or list the employees. Any of those would be okay. List the employees who make more than 30,000. Okay? So that's the plain English that I'm talking about. Okay. Next operator we're going to look at is rename. Right. Now we're going to look at this rename operator. And the rename operator is row. Okay. This is on that normal forms handout. And this is the only attribute I will let you combine, or not operator, the only operator I'll let you combine with other relational algebra operators. When we get to aggregation, you'll see why. Okay. But let's look at how we actually do this rename. So I'll use the project to help us out here at first. All right. And in this, I'm projecting the first and last name. Okay. So that should look familiar to you so far. And then, however many attributes I have inside these parentheses here, okay, I have to have, I'm going to do a rename, I need to list all those attributes. Okay. So I'm taking F name, renaming it to first name with first underscore name. Taking L name, underscoring to last underscore name. Okay. Now, in the way I treat these names in my class, I want these to be good variable names. Okay? Because most of the SQL statements you write, you will be creating arrays that will be passed back to an application program. And the way to access the data in those arrays is through the column name that we have. And that column name is either F name, L name, or first underscore name, last underscore name. Okay? Those are examples. So all the attribute names we have in these company databases, they would be okay attribute names, right? And that's what I want. If we rename anything, I want you to make sure that it's a good attribute name that could be used in a higher level language. So, in this case, we're just renaming first name, last name. Okay, from F name, L name to first name, last name. Can do a similar thing here if we're still going to do the renames, but we'll do a select first. So here we're getting all the folks that make more than 40,000, and we're listing their first and last name, and we're renaming it to first underscore name, last underscore name. And that's really it. The rename's a fairly simple operator. You just need to make sure that however many attributes are coming from whatever's inside those parentheses, that you rename all of them. Now we're going to look at what is called generalized projection. And it says it allows for functions or attributes to be included in that projection list. Okay. Now, let's see what that actually means. So I have an example here. Okay, list the first name, last name, the salary, and what the salary would be if it was increased by 8%. Okay. So I'm putting it into an intermediate relation called tax. I'm using row. Okay. But here's what the projection list is. Okay, I've got F name, last name, salary, and then salary times 1.08. And that would increase the salary by 8%. Right? So it's really to allow you just to do some sort of math in there. That's all it is. Now I'm renaming this to increase salary, INCR salary, because if not, it would be salary star 1.08. That's probably not a really good variable name for anything. Okay? So that's why I did have row on here to rename it to increase salary. Okay. If you want to see SQL for this, and I haven't been showing SQL quite as much as I meant to, but this is the projection list up here. Here's how I put that into the increasing the salary. And then I'm using this. This is a rename. Okay. In SQL, we call it a column alias. I didn't need to rename the first three because I'm just using their name. But this last one, I'm calling salary times 0 or 1.08. I'm calling it increased salary right there. So when I run this, that's how it looks like. Okay. We get the first name, last name, the salary, and then the salary increased by 8%. Now I want to show you what this would be if I didn't include that column alias. I would run this, and that would be the attribute name. Not a really good attribute name. Or a variable name for another language like PHP, C++, Java. Not a great variable name. That's why we do the renames. I call it increased salary, and that's a pretty decent variable name. Okay, so really the generalized projection means that you can take an attribute and do something to it, and then that's what will be output. Now we're going to take a look at how we can aggregate data in relational algebra. Okay, and you can see there we're using some aggregate functions. That's what we'll be using. Okay. Now the functions that we have are these. Okay. We can have functions that are applied to numeric values. We have sum, average, max, or min. And then it is a function, so you need to put what attribute that you will be aggregating. Okay. And then we'll also have a function to count tuples. Okay. Most of the time, you will be using count star. There's only two exceptions to this. Okay. One, if you have to count distinct occurrences of an attribute, or if you're going to do an outer join and then test the attribute for being equal to null. Other than that, you should always, 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 always just use the star or the asterisk within the parentheses, because we're counting tuples. We are not counting an attribute. If I said count, F name, Okay, and just did that, I'd get the same as count star because I'm not counting first names. I am counting how many tuples are in the relation. Okay? So use count star with the two exceptions of if you are testing for null with an outer join, or if you have to count distinct occurrences of an attribute. Okay? So let's look at what the syntax looks like here. It'll look like this. Let me turn off that bullet. So it's a grouping attribute or attributes, and those are optional. If you're going to aggregate across the entire table, you don't need a grouping attribute. Then you need the function list. And then function list can be count, it can be sum, max, whatever the function list is. And then the relation that you're going against. That should probably also be an R. So out of this, now this is one thing where I see students make the most mistakes. When you do aggregation, you're going with just one grouping attribute. You will have the grouping attribute and you will have the results of the aggregation. Okay? That's it. You will not have all attributes from the relation, and that is probably the problem I see the most with students in relational algebra. They don't understand what is returned from the script F or the aggregation. They think it's all attributes. If it's all attributes, then you don't have the results of the aggregation. Okay? So what is returned from script F is the grouping attribute and the results of the aggregation, and that is it. Okay, so let's see an example or two of this. See what it looks like. So here's one. We want to compute the average salary of all employees. Okay. In this case, I don't have a grouping attribute because I'm doing it across the entire table. And I'm doing average. Notice I have salary there from the employee table. I put all of that in parentheses, and then I do a rename. If I didn't do a rename, the attribute name would be average with salary in parentheses. So I give it a good attribute name that could be used in as a variable name in a language. Right? And this is what would be in the resulting relation, in result there. We get the average salary, and it was computed from the employee table. Okay. Let's look at one now where we're going to use a grouping attribute. Okay. Here I compute the average salary of employees by department. Okay. So I'm still in the employee table, I'm still averaging salary, but I added a grouping attribute. So what the grouping attribute will do, it will look in here and it will group all the Dino 5s together. It will group all of the 4s together. It will group the single 1 with. Okay. Then after it has grouped those together, it will go through in each group and take the average of the salary in the groups. And then that's what will be returned. Okay. So that's how a grouping attribute works. And just to show you a little bit how the grouping attribute works with aggregation, I should say. All right, I want to show you how this aggregation and grouping works in SQL. Okay. First thing I want to do is show you just aggregating the entire table. Okay. So I'm going to average salary, I'm going to rename it, but get it from the entire table. So when I run that, there's the average salary for the entire company. Okay. Now, the next one here, I'm actually going to be grouping. Notice the keywords group by. This is the grouping attribute that we saw right there. Okay. So we use that grouping attribute, we do the same thing. Up here, this is our projection list. We're going to project the department number and the average salary. So when I run this statement, you'll see a little bit of a difference. There I get output for each of the department numbers. We only had 3. That's why we have 3 rows returned. Okay. So that is how aggregation works, both in relational algebra and a little bit of an introduction into it in SQL. Now that you've seen how several of these relational algebra operators work, I want you all to do some practice on your own. Okay, so I'm going to give you a problem. I would like you to go ahead and pause, try to write out what you think the answer is, and then I'll show you the answer. Okay? Please pause and do this. If not, the first time you're going to be relational algebra is on the assignment. So I'd rather have you practice now so you can see the mistakes and then learn from that so you don't make those mistakes on the assignment. Okay? So the first problem I want you to do is this. Okay? List the ESSN and the number of dependents for the employees who have dependents. Okay? So go ahead and hit pause and do that, please. Okay, let's go ahead and see what the answer to this looks like. And there we go. Notice I had to use script F because I'm counting. I used a star because I'm counting tuples, getting it from the dependents table, and I'm grouping by the employee social security number. Remember, script F, in this case, I have one grouping attribute, so I will only have two attributes returned. The grouping attribute and the results of the aggregation. And that's why I renamed it, otherwise that would be called count star, and that's not a great variable name. So there's one of the practice problems. Let's go ahead and look at another one now. In this one, I want you to list the department number of any department which has more than one location. So go ahead and hit pause and work on this, please. All right, let's go ahead and see the answer to this one. Here it took me 3 statements to do it. Okay. The first thing I needed to do is do some aggregation. I needed to count how many locations each department had. So I'm using D number for the grouping attribute, and then I use count. Right? And then I have D number and number locations, and you can see that over here. Okay. Then I'm selecting where the number of locations is greater than 1. That will limit the tuples. I still have the same number of attributes though. And then once that's done, I go ahead and I just project the D number, and we're done. Notice how result is the last intermediate relation name there. And that's what I want you to use. Okay, so let's look at another practice problem now. Let's try this one. Okay, list Social Security number of any employees worked a combined total of 20 hours or more across all projects. Okay, so go ahead and hit pause and let's look on that one, work on that one. Okay, and here's what the answer will look like. Again, we're doing some aggregation. This time we're doing sum. We've got to sum the hours. Right? We're going to have, as a result, just those 2 attributes, the grouping attribute and the results of the aggregation. Then I do a select, and notice it says 20 or more hours, so I've got to use that special greater than or equal to symbol that's in here. Okay? We go up to that top page, you can copy and paste it from there. Do not put greater than symbol and then the equal symbol. You will lose a point for that. Okay, so use the symbols provided, please. And then we project the ESSN, and we're done. Got a few more practice problems, so let's look at another one here. And again, I hope you're pausing and trying to write these. Okay. All right, list the project numbers for any project controlled by Department 5. So go ahead and hit pause and let's work on that one. Okay, and the answer to this one is this. We simply do a select where the D-num is equal to 5 in project. That returns all attributes. We're not aggregating or anything, we're just selecting. And then we project the project number from there. So that one was a bit simpler than the previous two. Let's go ahead and look at another one. This one will be using some generalized projection. Let's first last names of each employee, their salary, and what their salary would be if it was increased by 10%. This time I'm also telling you what the attribute name should be. Okay, so go ahead and hit pause and let's work on this one. Okay, and the answer to this one looks like this. Okay. The generalized projection is right there. It's pretty similar to the example that I showed you earlier. Okay. And here's where we got the renames going on, renaming all of those columns except, well, salary stays the same. Okay. And then you can see what's in the results. Okay, we got one last practice here. Okay. And this is it. Okay, list the project number of any project where the combined total hours charged to it is less than 20. All right, so go ahead and hit pause and let's work on that one. Okay, and the answer to this one is, here we go. First thing we need to do is sum the hours, grouping it by the project number. Then we do a select to find the tuples that have less than 20 hours. And then after that, we project the project number off of those. Okay. And that ends up the practice. Okay. So make sure that when you write, they'll have one problem that says plain English. Make sure you word it something like this. Do not get very detailed. Remember that plain English is what a business user would say to you. Okay, that's the end of this video, and we'll talk to you in the next one.